Alright, let's start our conversation about parallel lines and angles. Our first objective is that we want to identify angle pairs and relationships associated with parallel lines and a transversal, and we want to calculate measures of angles associated with parallel lines and a transversal. Alright, so some vocabulary. Everybody pretty much knows what parallel lines are. They're lines that are in the same plane that do not intersect. A transversal is a line that intersects two or more other lines at different points. So if we have these parallel lines and they're cut by this third green line, the green line we call a transversal. Alright, we already know what vertical angles are, two angles whose sides form opposite rays. We also know, and we always have kind of described them as angles that are across from each other, and we know that those have equal measure. We've also talked about corresponding angles. When two lines are cut by a transversal, the angles of each line that are in the same location. So these are both in the upper left, they would be corresponding angles, and one of the things we talked about was if they have the same measure, then the lines are parallel. What we haven't talked about yet are things that we call alternate interior angles. So the alternate interior angles are angles on the interior of two lines and on opposite sides of the transversal. So the alternate part meaning that they are on alternate sides of the transversal, and the interior part meaning that they are between the two parallel lines, or really two lines. They don't necessarily have to be parallel, although most of the time they will be. So these would be examples of alternate interior angles. Similarly, alternate exterior angles are angles on the exterior of the two parallel lines and on opposite sides of the transversal. Same side interior angles are angles on the interior of the two lines and on the same side of the transversal. So angle 1 and angle 2 would be considered same side interior angles. We've already talked about the vertical angles theorem. Vertical angles are always congruent to each other. We can look at angle 1 and angle 2 and we know that they are congruent to each other. So if angle 1 is equal to 100, we know that angle 2 is equal to 100. The alternate interior angles theorem. If two lines are parallel and cut by a transversal, then the alternate interior angles are congruent. So angle 1 is going to be congruent to angle 2. Now I'm just going to quickly prove this to you. Okay, so what I'm going to do is just show you very quickly. I know that the lines are parallel, so that means that this angle right here has to be congruent to angle 1. That has to be congruent to angle 1 because they are vertical angles. And therefore, this angle, which we can call angle 3, I guess, is congruent to angle 2 by corresponding angles. So that's because I know that these lines are parallel. If these lines are parallel, I know that the corresponding angles are congruent. So therefore, angle 1 and angle 2 are congruent. Alternate interior angles of parallel lines are congruent. We don't like to write this all out, so we can abbreviate alternate interior angles as AIA if we want to. Alternate exterior angles are essentially the same thing. If we want to show that if we have two parallel lines being cut by a transversal, the alternate exterior angles are congruent. We just proved that the alternate interior angles were congruent if we have parallel lines, so I know that those two angles are congruent. And then by vertical angles, I know that this angle and x will be congruent, this angle and 70 will be congruent, so therefore 70 and x would be congruent to one another. The picture is not a great demonstration of this. Now we do this for a reason, because we don't want to just assume that the diagram necessarily is Yeah, I know that looks like an obtuse angle, but sometimes the angle is going to look obtuse in the diagram, and your answer may end up being an acute angle, or what you think is an acute angle. So we do this for a reason. Alright, the corresponding angles postulate is one that we've already talked about. We have two lines being parallel and cut by a transversal, and therefore the corresponding angles are congruent. Here are my parallel lines right here, and so 120 and x are going to be congruent to one another because those lines are parallel. Same side interior angles. If two lines are parallel and cut by a transversal, then the same side interior angles are supplementary. So 50's supplement would be 130 degrees. If you think about it, this angle by alternate interior angles would be 50 degrees. This angle will form a linear pair with this angle. So we would just take 180 minus 50 to get 130, and we can see that those are supplementary angles. So in a summary, and this is what I would want you guys to write down, and I would like you to draw pictures. Vertical angles are congruent, so draw a pair of vertical angles, draw corresponding angles, draw alternate and show that they are congruent. Draw alternate interior angles, show that they are congruent. Draw alternate exterior angles, show that they are congruent. Don't really worry too much about the same side interior angles, but really it's these four that are the biggest that you'll need to know. Alright, so we're going to do a couple quick example problems just to make sure that we're all on the same page here. Alright, so angle 5 and angle 2 are, what I'd like you to do is answer the question, and then pause the video at this time, answer the question, and then you can check your answer. Okay, so you should have said that angle 5 and angle 2 are vertical angles. Look at their position in the diagram. So they are kind of across from each other, they're vertical angles. Angle 6 and angle 7. Okay, I want you to try to answer this question. Okay, you should have got that angle 6 and angle 7 are same side interior angles. They're on the same side of the transversal and on the interior. Alright, we want to know the value of x. So what I want you guys to do is try this problem and see if you can answer the question. Okay, so by alternate exterior angles, we can say that 5x is equal to 110. So that's the equation that we can write. And then if you divide both sides by 5, you would get that x was equal to 22. So D would be your answer there. Alright, so now we want to know the value of y. So try this problem. Okay, so the value of y, 110 and y are supplementary angles, so I would do 180 minus 110 to get 70 as the value of y. For number 5, I'd like you to try this problem. Okay, so for this one you should have gotten 132 as your answer. To get 132, since they're vertical angles, you should have set angle 1 equal to angle 2. When you solve for x, you get x is equal to 8, but then that's not the answer to the question. The question is, what's the measure of angle 1? So you have to substitute 8 back in to the measure of angle 1 to get your answer. Okay, we want to find the measure of all of these other angles. So given the fact that this angle is 80 degrees, try to find the measures of these other ones. And one thing that we are going to know, you can't do this unless you know this, these lines are parallel to one another. Okay, so let's start with the angles that are going to be congruent to 80 degrees. Angle H is going to be congruent to 80 degrees because they are corresponding angles. H and E are vertical angles, so they would be equal to 80 degrees. So H should be 80, E should be 80. Now A should be 100 degrees. 180 minus 80 is 100. So now the other angles, C is vertical to A, so it will also be 100 degrees. D is corresponding to A, so it will be 100 degrees. And G is vertical to G, or is vertical to D, so it will also be 100 degrees. You could also say that A is congruent to G by alternate exterior angles. You could have gone from A to D to G. You could have gone from A to C to D because they're alternate interior angles. It doesn't really matter. But all of those angles, A, C, G, and D, would all be 100 degrees. Okay, so that ends our slideshow for this. What I want you guys to do now is we're going to work on some problems from a lesson master, and we'll see how we do.